Now we will start our new chapter, Light and Plane Mirror. Now we will learn about the definition of light and the characteristic of light. Light is electromagnetic radiation that can be detected by the human eye. Light has dualism properties. First, as matter, because the light has mass and momentum. The second, light as a wave, because it was reflected and refracted. As a wave, light travels in the straight line until it hits something else. The direction of a very narrow path of light is known as a ray. The ray of light is represented by a straight line with a narrow head that the direction of the arrow head shows the direction of ray's propagation. The collection of the rays of the light is called the beam of rays. There are three types of beam rays. The first beams are parallel beams. The second beams are the convergent beams. The convergent beams if all rays collected to one point. The third beam is divergent beam. The divergent beam if all rays scattered from one point to all directions. Now we will learn about the reflection of the light. To understand the reflection of the light, first we should understand about the Snell's law. We usually say it as the laws of reflection. The first law is the incident ray, reflected ray, and the normal to the reflecting surface at the point of incidence lie in the same plane. Atau bisa dikatakan, sinar datang, sinar pantul, dan garis normal terletak pada satu bidang datar dan ketiganya berpotongan pada satu titik. The second law is the angle of incidence with symbol I is equal to the angle of refraction with symbol R. To understand the laws of reflection, we can see from the figure below. As you can see, incident ray come to the reflecting surface. After that, the ray will be reflected by the surface, and there is normal. First, we should understand the definition of normal line. The normal line is the line that perpendicular with the reflecting surface. The second is in the incidence angle with symbol I is the angle that created between normal line and incident ray. And the last, reflected angle with symbol R is the angle that created between normal line and the reflected ray. Related with reflection, object can be divided into two types. The first object is object that can reflect it always. The object is shiny object like mirror and metals. The second object is the object that can reflect it always. The object is dark object. While we talk about the reflection, there are two types of the reflection. The first is regular reflection. Regular reflection is reflection that occurs while all parallel rays comes to the flat or smooth surface, so that the rays reflected parallel to. The regular reflection you can see from the figure below. As you can see, all parallel rays that come to the smooth surface or flat surface will be reflected parallels to. The second reflection is diffuse reflection. Diffuse reflection is reflection that occurs while all parallel rays comes to the rough surface, so that the rays reflected doesn't parallel again. Or we can say the rays are scattered. The diffuse reflection you can see on the right figure below. As you can see, the parallel rays that come to the rough surface is reflected not parallel anymore. Now we will learn about the reflection on flat surface, which is plane mirror. Before we learn about the reflection on plane mirror, first we need to understand. In image formation on plane mirror, needed minimum two rays that come from the object. We have to remember all rays that come from the object. Now we will learn about the process image formation for object point. From the figure, you can see from the object, the ray come to the mirror. The first ray that come to the mirror is coincide with the normal, so that we can say that the ray come with incident angle 0 degree. As you can see, the line is shown by the blue arrow. After the ray come to the mirror, the ray will be reflected. Using the second law of reflection, that incident angle is equal with the reflected angle. Because the ray come with incident angle 0 degree, so we can know that the ray reflected with angle 0 degree. As you can see, the reflected ray is shown by red arrow. From the figure, the second ray that comes from the object to the mirror, that's shown by the black arrow, come with angle 30 degree. Using the second law of reflection, that the angle of reflection will be the same with incident angle. As you can see, the two reflected rays from the mirror doesn't intersect one to each other. But if the two reflected rays is extended using dashed line, as shown by the green arrow, the two dashed line will be intersect in one point behind the mirror. The position of intersection between two dashed lines is the image position. And the image that created by two extended reflected rays behind the mirror we call as virtual image. Now we will see the process image formation for line object. Now See the figure below. Because the object is the line object, we should understand about the line. The line is the group of points. Because of that, the line object can be considered as the 2 points at the tip of the line. The first point, the ray comes to the mirror as shown by orange arrow. The ray comes with incident angle 30 degrees. Using the second law of reflection, the ray will be reflected with angle 30 degrees too. The second ray that comes from the first point object, that's shown by purple arrow, is coincide with the normal line. Because of that, the incident angle of the ray is 0 degree. Based on the second law of reflection, we know too that the reflected angle of the reflected ray will be 0 degree too. Because the two reflected rays doesn't intersect one to each other, so the two reflected rays will be extended behind the mirror using this line, as you see from the figure is shown by red arrow. The two dashed line will be intersect in one point behind the mirror. The intersection between two dashed line will be the image position. Using the same way, at the second points, we will get the other image point behind the mirror. And the two image behind the mirror will be connected with the dashed line. The dashed line is the virtual image because it is created by the intersection by two dashed lines. After we learn about process image formation on plane mirror, we know there are several image properties created on plane mirror. The first property is virtual. Virtual image is image that created by two extended rays that intersect behind the mirror. The second is upright. The third property is, as we can see from the figure, the distance of object to the mirror is the same with the distance image to the mirror. The fourth property is the size object is the same with image size. And the fifth property is laterally inversion. It means that image position is on the opposite position from object's position. Now we will learn about image formation from the object that located in front of the two plane mirrors that created angle alpha. An object that placed in front of two plane mirrors that created angle alpha. So, number of image created can be formulated with formula n equals 360 per alpha minus 1. N is symbol for number of image created by two plane mirrors that makes angle alpha. And alpha is angle created by two plane mirrors. Example: determine number of image created by an object located in front of two plane mirrors that makes angle 90 degree. From the problems, we know that the angles between two plane mirrors is 90 degrees. So in here we know that alpha is equals 90 degree. And from the problems, they ask about number of image created by two plane mirrors. So they ask about n. So using the formula n equals 360 per alpha minus 1, we know that the number of image created by two plane mirrors equals 360 per 90 minus 1 equals 4 minus 1. So the number of image created is 3. Now we will see process image formation, an object that located in front of two plane mirrors that created angle 90 degrees. Process formation of image is drawn in a circle. To simplify it in drawing image formation, the two mirror is drawn using shaded behind the mirror, and the mirror is extended. The two mirror is extended using dash line until the dash line intersect the circle. From the object, the first ray that comes to mirror 1 is reflected, and the reflected ray on mirror is extended to the back of mirror. At the back of the mirror, the extended ray will intersect between extended ray and the circle. The intersection is image 1 location. Using the same way, the ray that comes to the mirror 2 is reflected, and the extended ray behind mirror 2 would intersect the circle. The intersection is location of image 2. After that, the ray that comes from image 1 and image 2 and perpendicular with the extended of mirror 1 and 2 is extended behind the mirror. The extended ray will intersect with the circle behind the two mirrors. This position will be the third image location. Now we will learn how to determine incident angle and reflected angle of the light on several plane mirrors. Now look at the figure below. From the figure, the ray comes to the mirror 1, that the angle between the ray and the mirror 1 is 30 degrees, and the angle between mirror 1 and mirror 2 is 120 degrees. And here, determine incidence angle and reflected angle on mirror 1 and mirror 2. The answer for the problems above, as we can see on the figure, the ray that comes on mirror 1 and mirror 1 created angle 30 degrees. And we know that normal line is perpendicular with the mirror 1. Because of that, we can get the incidence angle on mirror 1 as shown by blue arrow. Incidence angle on mirror 1 equals 90 degree minus 30 degree. So the incidence angle on mirror 1 equals 60 degree. After we get the incidence angle on mirror 1, by using the second law of reflection that said incidence angle is equals with reflected angle, so we can get reflected angle on mirror 1 as shown by orange arrow. So in here we can set reflected angle on mirror 1 equals 60 degrees too. After the ray is reflected by mirror 1, now we can get the angle between the ray that reflected by mirror 1 and mirror 1 is 30 degree. And because the mirror 1 and mirror 2 created angle 120 degree, because of that, we can get the angle between the reflected ray on mirror 1 or incident ray on mirror 2 and mirror 2 is 180 minus 120 minus 30 degree. So the angle between incident ray on mirror 2 and mirror 2 equals 30 degree. After we get the angle between incidence ray on mirror 2 and mirror 2 is 30 degree, now we can get incidence angle on mirror 2. Incidence angle on mirror 2 equals 90 degree minus 30 degree as shown by black arrow. So this angle on mirror 2 equals 60 degree. After we get the incidence angle on mirror 2, we can determine reflected angle on mirror 2. Using second law of reflection that said incidence angle is equals with reflected angle, we can say that the reflected angle on mirror 2 equals 60 degrees too. Now we will learn how to determine minimum height of the mirror so the whole image of the person can be seen on the mirror. From the figure, we can see that the height of person h equals s plus d, and the minimum height of the mirror L equals half times S plus half times D. So, from this we can conclude that minimum height of the mirror L equals half height of the person. Now we can see the example. As you can see from the figure below, determine minimum height of the mirror so that the person can see all of his image in the mirror. As you see from the figure, the height from the eye to the head is 0.1 meter, and the height from the eye to the foot is 1.5 meter. So now we know that the height of the person equals 1.5 meter plus 0.1 meter equals 1.6 meter. So from the formula at the previous slide, we know that the minimum height of the mirror equals half times 1.6 meter equals 0.8 meters.